Hi guys, so today we're going to talk about scatter plots and what they're used for and why they're useful. So it's a different type of graph. Obviously, it's got a bunch of dots on it. And notice that it's on kind of in the first quadrant of a coordinate plane. It's all positive x's and y's in all of these examples, and usually they are that way. But the x coordinate all has a title underneath these four, and the y values all have a name going up there. So a scatter plot is plotting points on a coordinate plane, and let's look at what they are. So it shows a correlation between two quantities. It must be numerical values. That's what we're comparing, like certain numbers to another number on a scatter plot because we're plotting points, right? An XY value. Scatter plots show us trends like, oh, all of these dots seem to be plotted going in a certain trend in a certain direction. And they help us make guesses for unknown variables if we see those trends. So a correlation is just the relationship between the two variables. In this first graph over here, this is a positive correlation because as time spent studying increases. So this bottom, the X value is time spent studying. So hours would be down here. Students' grade increases. So the less time these people were studying, this data shows that their grades were increasing. That's called a positive correlation. On this graph over here to the right, as we spend, what is this, amount of time spent training, so the more time you spend training, then this variable seemed to decrease time to run the 100 meters. So the more time you trained, the quicker your score was, or the lower the number was on your run, right? So that's called a negative correlation. Doesn't mean it's a bad thing. It just means that's the trend. Most of these points are all going down to the right. Though X is increasing, the Y is decreasing. All right, this one over here, as the number of people increases, the cost is constant. So it doesn't matter what the X is, the Y is always about the same. It's always around 25 over here. So the number of people in the car compared to the cost at a parking something at the Verizon Center. So there's really no correlation between the number of people in the car and how much it costs to park there. So this one is no correlation. Same thing over here. There's really no relationship between the test scores and the suit and somebody's shoe size. So these are all over the place. So there's no correlation between this data. So this scatter plot shows the price of menu items at Chez Henry compared to the average number of times that item is ordered each night. So this is price. So take a look at the scatter plot. This is the price. So something is $12. This is how many they've ordered. So as the price increases, notice what happens with how many people order that item, right? So this thing that's $27, 5 is the number of orders for that $27 entree. So how many items are on the menu? Not quite, can't quite figure that out based on this graph. What is the correlation? We can. This is pretty much a negative correlation. And as the price increases, the number of times it is ordered decreases. So people just order less of the more expensive items on that menu. If the data shows a general trend like this, we can use a line of best fit. And it's like a line that will kind of cut through the middle of all these X's. And it kind of delineates the trend. It kind of shows us what's happening. And it basically better shows the relationship between these two sets of data. All right, this scatter plot shows the amount of gas used on different car trips. So we can use the line of best fit and make some predictions. So how much gas will be needed to drive 220 miles? So here's our miles at the bottom, 220 is right there in the middle. About how many gallons of gas would it needed to go that far? If you say anywhere between 4.5 and 6.5 gallons, that's a good estimate, predict how much. Now we're going to look at how many miles can be driven on 5 gallons of gas. So now I'm looking at the Y value and kind of making a prediction that maybe about 150 miles can be gone on 5 gallons of gas, right? So we can make predictions based on these trends that we see here. So there's also something called an outlier. This scatter plot we looked at a couple slides ago, these 2 points out here are outliers. They're points that aren't they differ significantly from the general trend. Like they're just completely different. Over here, this guy over here, pretty much an outlier who's not really following the general trend of this data. All right, let's look at this scatter plot. It shows the relationship between Josh's age and the time it took him to run a mile. So as he got older, his mile time got less. So this correlation is a negative correlation. And as Josh's age increased, his time and the mile decreased. For how many years did Josh track this information? It looks like he didn't start until he was 11, right? And he stopped when he was 17. So this shows about 6 years of data. If he wants to predict his mile time for age 25, should he use this graph? Why or why not? So think about what these data points are. This is time to run a mile. And really, you can only get so fast at running a mile, right? So as he gets older, it might get a little bit better, but then it's probably going to flatten out. And as he gets even older than that, it might even go back up, right? So definitely, I wouldn't use this graph to predict at 25 based on the variables that are used in this situation. All right, guys, hope that helped. Let me know if you have any questions.